Chapter 25, Section 5, page 818. The origin of the solar system. Figuring out how the solar system formed is a bit like detective work. You can't go back 4.6 billion years in time to see exactly what happened, but there are many clues that scientists have used to form a theory about what must have occurred. Any such theory must explain why all of the planets' orbits lie more or less in a single plane, and why all of the planets orbit the sun in the same direction. It must also explain the difference in size and composition between the terrestrial planets and the gas giants. The nebular theory. The generally accepted explanation for the formation of the solar system is the nebular theory. The nebular theory states that the solar system formed from a rotating cloud of dust and gas, and that's a key idea. The nebular theory states that the solar system formed from a rotating cloud of dust and gas. A large thin cloud of dust and gas, like the one that eventually formed our solar system, is called a solar nebula. According to the nebular theory, the solar nebula formed from the material expelled by previous stars. Page 819. It is likely that a shock wave from the explosion of a nearby star caused the solar nebula to collapse. The nebula most likely began with a slight overall rotation. As the cloud contracted, it began to spin faster. The gravitational attraction between particles became stronger as the solar nebula shrank, accelerating the process. Formation of the protoplanetary disk. As the solar nebula rotated faster, it began to flatten out. Over about 100,000 years, a large disc-shaped cloud of dust and gas called a protoplanetary disk formed. Looking like a giant fried egg rotating in space, the disk was densest at the center and thinner towards the edges. The planet would eventually form from the outer parts of the disk. Nearly all of the mass in the solar nebula, about 99.9%, became concentrated near the center. The sun would eventually form in this region. The enormous density at the center of the disk increased until the temperature reached a few million degrees. Then, about 10 million years after the formation of the solar nebula, nuclear reactions began to fuse hydrogen into helium. Our sun was born. Planetesimals and protoplanets. The nebular theory also explains how the planets could have formed. Within the contracting protoplanetary disk, dust grains collided frequently. Weak surface forces held these dust grains together, forming loose balls of dust. As these balls of dust collided, they grew larger and larger. Scientists estimate that after a few million years, there were about 1 billion planetesimals revolving around the sun. Planetesimals were asteroid-like bodies that eventually combined to form planets. Planetesimals grew by accretion, the process of adding mass by colliding with other planetesimals. Once planetesimals became larger than about 1 kilometer in diameter, they began to exert a significant gravitational attraction on nearby objects. The planetesimals attracted more material, causing them to grow even faster. The result was the accretion of planetesimals into a much smaller number of moon-sized protoplanets. These protoplanets eventually joined to form the current planets in a series of immense collisions. The nebular theory provides an explanation for the current motions of the sun, planets, and most moons. Nearly all are now revolving in the direction that the protoplanetary disk was spinning.